I decided to do this because there are certain other concepts around security that were not treated and are important to understand. Plus, the entire banter I saw on the group, I didn't. I just decided that it was important for you guys to understand how the web works, so that we don't have this misconception when somebody just decides to come online and look for attention, to draw our attention. Okay, so like I said, the purpose of this meeting is to address certain concepts around the web and continue to improve our knowledge on certain aspects of security. Now, who should be interested in this? Anybody interested in ethical hacking, or anybody interested in application security? Or if you are in the defensive side, your understanding of the web generally will enable you to identify the vulnerabilities that you need to guard against in the first place. So let's get down to the class. We'll be talking about the web in depth. That's what I decided to name this series. And we'll begin with API security fundamentals. Okay. The agenda will cover basic introduction to APIs, common API threats and vulnerabilities, a practical session with a vulnerable API where I will explore or exploit one of the number one OWASP vulnerability for APIs, and then core principles of API security, and then I'll have a question and answer session. We have to begin, before we talk about API security and all the jargons that come with it, we have to begin by identifying what are APIs. Some of us may be familiar with what APIs are. APIs, standing for Application Programming Interfaces, in simple terms, are basically the way applications connect with each other. It involves a set of protocols that enable different software components to communicate and transfer data. I'll be making reference to the scandal, I'll call it that. The scandal, what's his name again? The very dark man finance app stuff. Although I didn't follow it up, but I knew it was a finance scandal or something. So we'll be talking about finance APIs. So imagine your typical finance application, your typical bank app, Access Bank or whatever, has a user interface where you communicate, you see your details, your bank balance and all that. What enables you to view those details, perform transactions and other functions on that application is the API, right? Is the API that the developers have used to communicate with that user interface and it grants you the functions to perform whatever action you want to take. Developers use APIs to bridge the gap between small discrete chunks of code to create powerful, resilient and secure applications that can meet user needs. I remember during our class we talked briefly about web what was it? It was web application security. Yeah, I remember. So it was web application security. We talked about the front end, we talked about the back end, and we talked about the infrastructure that governs the creation of these applications or these softwares, right? In the digital world, in the digital world now, most of the businesses must run on one software or the other if it wants to thrive, right? So you can imagine that for those businesses to run, they must have data stored in a database, they must have functions on the cloud or on the server. They don't just have UIs lying around. And for them to communicate with those servers or those places that they store their business information, which is the database, they need an API. Now, this API serves as a gateway, right? A typical finance application has databases to store user information and all the user account details. Now, the API is what will get those account details for the user when he or she wants to access it. Okay, moving on. Why should we study or API security? Why is API security important? We say API security is important because, as I've tried to clarify now, APIs are the backbone of any software application. In fact, some hardware applications that utilize real-time data would also utilize APIs to get those data. So, APIs are one of the major targets of any application or of any attack on an application. Why? Because APIs have direct access to sensitive data. When you look at the typical application, if it's a fintech application, one of the ways by which the attacker would want to attack that application is through the API, because the API contains a whole lot of data and it has access to the servers. Another reason is APIs are usually over-permissioned. Over-permissioned in the sense that we have talked about the concept of defense in depth and the concept of least privilege, right? I believe we are familiar with those two terms. Now, when designing a system, you would want to ensure that, okay, only certain people have access to certain data. But in the case of APIs, some developers would grant APIs certain privileges, or grant roles within APIs certain privileges that are not meant to be accessed. Let's say an admin or a typical user having certain features that only an admin user would have. And this can be exploited to perform attacks like privilege escalation. Another reason why APIs are targeted by attackers is the vulnerability of logic flaws. This is where your understanding of what the company or what the organization is trying to achieve comes in. As a security personnel or as a developer, you need to understand the logic or the business logic behind what the API is meant to function as. A fintech application, the logic behind granting withdrawal functions to the user is entirely different from the logic behind granting authentication functions to the user. So understanding this key business logics will enable you as a security personnel understand where within the application should have certain permissions, and enable those who are security engineers or developers to understand the functionalities to build around certain features. Now, if you look at this image displayed here, it's trying to represent the versatility by which an API operates. APIs are not just limited to one particular backend or server, right? And a typical application could use microservices, services on the cloud, internal services, public APIs, or connect to various other applications. So you can imagine that the threat landscape has already increased. And so in this case, a typical vulnerable API is a risk to the business. Another reason why APIs are such interesting targets is that they are more direct to attack. If you have come across the term, the cyber kill chain, it is the classic cyber attack used by attackers to penetrate or attack a network, right? This involves the attacker performing reconnaissance, trying to identify the vulnerabilities or the certain information about a particular network, and then trying to weaponize that information he has gotten to identify what is the best method he should attack this network. Then when he identifies that, he infiltrates the network. From there, perform some privilege escalation or literal movements, and he has successfully breached the application. You can see that this is a sequence of steps that the attacker has to take, right? But in the case of an API, the attacker just needs to find the vulnerability and then perform the breach. It's that direct because the application needs to call the API in the first place, so the API is open, right? So it just like instead of having your typical defense in depth, you are now having just one line of defense where the attacker just needs to identify one thing to be able to breach your application. So this is one of the reasons why APIs are so interesting. Now, it relates to the very dark man issue. If that had been true, the best way would have been him claiming that the attackers had utilized access Zenith Bank's APIs to perform debit transaction by probably getting his details through mass data exposure vulnerability. But clearly he does not have knowledge of that. So now we have identified the security issues that are the reasons why APIs are targeted. Besides having a typical application, you have now known that APIs, application programming interfaces, are another very important aspects by which we should protect. What are the common threats and vulnerabilities that are associated with these application programming interfaces? Just like you have your OWASP vulnerabilities for web applications or software, OWASP, the Open Web Application Security Project, also determined in 2019 that it is important to identify the key vulnerabilities that are associated with APIs. So they developed the API Security Top 10, right? In this call, we will only cover one, but I urge you to go to the OWASP websites and research these top 10 vulnerabilities. Some of them may seem similar to the normal OWASP top 10 for web applications, which you are familiar with. You have broken object level authorization, you have broken authentication, broken object property level authorization, and so on and so forth. For this call, we'll just cover broken object level authorization, right? But these 10 vulnerabilities are the most performed attacks on any API. So if you are a security analyst, SOC analyst, utilizing firewalls and other detection tools to protect APIs, then you should look out for these vulnerabilities, their characteristics. And if you are a penetration tester, you should look out for techniques to implement these vulnerabilities in your application. Let us observe how we can utilize the broken object level authorization vulnerability. Now, if you consider the broken object level authorization vulnerability, usually called BOLA, an attacker authenticates a user as a user A, basically saying he registers on an application as a user A, and then he attempts to transact and access information that belongs to another user. And if that attack works, he can iterate and continue this process probably through an automated means or manually. Either way, he will be able to harvest vast amounts of data from the API. This is the English way of defining this. If we are looking at the technical terms, the API, the broken object level authorization vulnerability utilizes APIs that tend to expose endpoints. I believe we are familiar with what endpoints are. Key resource locators within an application. Yeah. So APIs tend to expose endpoints that handle object identifiers and create a wide attack surface of object level access control issues. Now, these object level authorization checks should be considered in every function that accesses a data source using an ID from the user. Let us bring this back to our illustration of the fintech application. If I am a Zenith Bank user, and let's say we have a Zenith Bank community where all users report certain information. Now, my details will need to be linked to that Zenith Bank community in one way or the other, maybe my name, my ID, or something. Now, Very Dark Man is also linked to that community as a Zenith Bank user, right? Now, if I am a black hat hacker, I can decide to utilize Broken Object Level Authorization to see if I can get access to Very Dark Man's account and perform certain transactions or functions using certain parameters or IDs or personal identifiable information that I get from his account. So it means that I am exploiting certain flaws in the design logic or the authorization code in that Zenith Bank application to attack Very Dark Man and perform transactions from his account when I am not logged into his account. I think that's the best way of explaining this. But we'll practice this and see it in more clear terms. How do we prevent this particular BOLA vulnerability? We have to define access control policies. We have talked about policies, parameters, we have talked about governance and certain other CIA triad concepts. Now, for this vulnerability, we are saying whether you are a security analyst or you are a developer, you have to define your access control policies. That is, identify which access and data a particular user or a given role should have. When developers or when an application is to be designed, when any network in fact is to be designed, you are to identify who will have admin privileges over this network and what features will fall under those admin privileges, right? And then enforce these policies at the application logic layer. Another way of preventing this BOLA vulnerability is to ensure that an authenticated user is authorized to request data, right? And then finally, implement automated testing to make sure that no exposures or gaps are being reviewed or entered into the application code logic. All right. This last point basically means as much as you have implemented or defined access control policies and set up input sanitization to ensure that only authenticated users have certain features available to them, you must constantly monitor your application, right? Using automated testing tools to ensure that they are not broken or your logic is not broken. Okay. Now let us go to the practice session where we will utilize an intentionally vulnerable API to practice the BOLA vulnerability. Well, the API we'll be using today is called CRAPI, CRAPI, right? It's completely ridiculous application programmer interface. That's the full meaning, right? So the CRAPI was developed by the OWASP, and it's meant to be intentionally vulnerable for you to exploit and discover with techniques to exploit the OWASP API top 10 vulnerabilities. All right, so it's just like your OWASP juice shop, but this is an API in this case. Now, the link to the repository for the CRAPI is, as you can see, is on the screen, and the tools you need for this CRAPI include tools like Postman, Bob Suite. I didn't include Docker here. You will need Docker as well, but that's for the installation. right? Now, let's see, how much time do I have? I will.
Sir, there is
We
time.
have just done 30 minutes.
Okay, okay, okay. I'm considering. No, I will send a link to. Sorry, let me add somebody. I will send a link to the group that contains uh, a documentation on how to install the CrapEye API. Or if that is too difficult, the CrapEye API is also hosted by the OWASP community. So you can access it by just typing crapeye.ai. Yeah. So for me, I'll be presenting from my Kali Linux, and I've already installed the CrapEye, so I will not cover the installation of the CrapEye. As the recording is coming up. Yes, it's being recorded now. Thank you. Okay. So first, go to where my lab is, which you will set up when you are practicing yours. And then I use Docker to compose and run my CrapEye configuration. So I have to wait for it to come up. James, for the extension I was talking about, this is it, Foxy Proxy. If you look at where my mouse is, yeah, you go to Firefox store and install it. Yeah. So it's still loading. Now, because my lab has not come up, I will not be able to access the CrapEye application or the Mailhawk email server. For the CrapEye that is hosted by OWASP, the link I called out earlier, you will not be able to access the Mailhawk server unless you install CrapEye on your virtual machine. That's the limitation. It's the CrapEye. When you install CrapEye on your, I'm running the CrapEye on my local host, right? For the emails that I'll be getting from CrapEye using that my Mailinator email address, they will be sent to my Mailhog server. So when I install CrapEye, I will configure the mail host server as well. So it comes together. Localhost is it just means you are running something on your personal computer. It's not live for others to see. Like the link I gave you for the CrapEye that's hosted live is crapeye.appsec.ai, right? That one is live for everybody to use. But this one now, if you look at my dashboard, my URL there is 127.0.0.1, right? Whenever you run, whenever you run a lab like this, it will always run on localhost until you deploy it. The only thing you have to define when you are creating it is what? Sorry, I just saw it. I don't like error. The only thing you have to define is the port that it will run on. So when you are creating any, when you are running any lab like this, it will always run on localhost. It's the port is that 8888 you are seeing at the end. No, it's just to assign a particular port. No, you have over 1,000 from your Mmap scans. You have seen that you have over 1,000 ports, right? Over 1,000. You can just assign a particular open number or a particular open port to that um, lab. API security, right? The core pillars of API security include governance, which include the development of secure API, and all that entails. Next is the testing, which ensures that APIs are free of flaws, and then monitoring, which is the detection or detecting of threats in a production API, right? So governance is all about defining, establishing, and enforcing the process of developing APIs from business logics to throughout the entire API development lifecycle and getting them into production. That's all what governance is about. Next, you have the testing, which is about ensuring that your API performs as expected and is free of vulnerabilities and other flaws which could be exploited, which is what we were trying to do just now. And then you have monitoring, which involves um, constantly or checking or monitoring the APIs to make sure that they behave as expected, right? So people on the offensive side will mostly focus on testing, governance, risk and compliance will okay, that's common. Governance, risk and compliance will focus on governance, while people on the defensive, such as incident response or um, SOC analysts, will be monitoring the APIs and their connected application. So, like I said, I would not recommend you using your original email. So you can go to this site, melinator.com. You can see it on my screen. It gives you the ability to create public emails for a duration, a short period of time. So I will create I'll create the email oracle@melinator.com. So I'll be receiving whatever mails comes to other users this account here, or I'll receive it on this mailhog server. So let's create this account. Clicking on insert. Here we can see that by clicking the refresh button, we get a response showing our car ID, and it's also part of the parameters that is in our URL, which means if we want to get another user's car details, it will come with the car ID. We have to use the car ID to get that. So if we can get the car ID, then we can get the user's details. And one of the best places to get information about various users will be from the community section. You can go here. By clicking this, we should have gotten a response from the API right now. We don't want to go through all this hard, long steps process of identifying each individual packet. We can intercept, but we'll not be doing that now. This is the API for the community posts. You can see community API version 2 community posts with a user ID or post ID. If we send this through the repeater, we can see we get the person's user post ID, comments ID, along with their vehicle ID. Now, this is the information we need to be able to get this vehicle information. We take this back to our previous request and replace our own vehicle ID with his. And we can send this and get our new user's vehicle ID as well as the location of his vehicle. So we earlier stated the implications of revealing such an information. Your vehicle could be stolen when they know where it's parked, various other things depending on the application and the use of the application.
Yes.
Okay,
Yes.
so by intercepting this proxy and sending it to the repeater, we got a response showing us the ID of that comment, the title of the comment, and the context. And because the comment was made by an authenticated user, they decided to show us the name, the email. But one thing that I feel should not be a part of this response is the vehicle ID of the user in a comment section, right? Because with this ID now, if we copy this and we go back to our initial endpoint for getting vehicle ID, location, and we paste that, we remove our own vehicle ID and paste his own, this is our own, and we run the function. Now you see we have gotten the vehicle location of this user. Are you getting the flow?
Yes. 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 I think you should take one bottle of beer.
Right. The now
James, na me and you. Oh.
you can see the logic, you can see the flaw in the logic here. I don't want to say, can someone say it's the flaw in the logic? We have already identified it.
Are you asking a question, sir?
Yes, the flaw in the logic that enabled us, we as it is now, we have been able to get the latitude and longitude of that user,
Okay. The flaw
right?
is the logic in the logic so far because of time is for them to include the vehicle ID in a comment section.
Exactly. One for one, that vehicle ID is not important in that feature, and two, it is mass exposure of data, right? So
Yeah.
the logic flow there is wrong, and we have
And I
successfully
think
exploited it.
and I think the mistake started from when they make it mandatory that you should provide that the vehicle ID before you can even create account or so or login or something.
You know, the vehicle ID is generated for you. The thing that they send to you is like a code. This VIN code
Okay.
is not your ID. This is not your ID. Okay.
Okay.
Yeah, it's just a code to generate a vehicle for you.
Okay.
In an actual website like this, you will be the one to create the vehicle. But since this website was designed with an API that is vulnerable, this is their way of creating the vehicle for you.
The vehicle.
Yeah.
Thank you.
So okay, we are short on time. There are other ways you can exploit the BOLA vulnerability on this uh, or any other application even. From this now, we have highlighted the basic logic flow, which we have identified as wrong. um, we said including excess data or unnecessary data in a particular feature such as community is a wrong step, right? For this now, we could take a vulnerability report format and detail what we have found and the procedures involved and report to the organization. Another way we can exploit the BOLA vulnerability on this particular app is we can get access to um, mechanic records of other users, right? Probably see more information about where their vehicle is and all that. Um, James, the you are sorry,
Yes,
the
sir.
longitude and latitude you can see it represented here. We can
Yes, yes.
it on any Google map. So